Hello, welcome to an awesome demo/tutorial by Vavetek.AI. We're here to guide you through the updated model of BAMROC and our CRDR plugin. Without wasting any time, I'm going to launch Revit 2024, which is the version I'll be working with for this demonstration. Today I've selected a small and simple project file that I'll use as an example for this tutorial. It's just right for helping you understand the workflow clearly and efficiently. Once your Revit is open and your project is loaded, here's what you need to do next. You'll start by selecting the first 11 categories in your model. These are the categories that are crucial for identifying clashes later. The categories include air terminals, cable tray fittings, duct accessories, duct fittings, ducts, mechanical equipment, pipe accessories, pipe fittings, pipes, and finally sprinklers. Once you've selected all of these, the model should be fully visible in your Revit workspace and you're all set for the next step. After that, it's time to export the model as an NWC file. This is the usual and essential step before moving into Navisworks. Now, just to save time for this video, I've already exported the NWC file in advance. I'll go ahead and open that NWC file inside Navisworks Manage. As you can see here, the model has successfully loaded and is ready for clash detection. The next thing we need to do is head over to the Clash Detective tool. This is where we'll check how many clashes exist in our current model. But before running the test, here's a very important step. Save your Revit model before the NWC export and label the file clearly, for example as TP01. This naming convention will help us stay organized, especially when we go through the results later. Now I'll press the export button and create the NWC file. The clash test type I'm selecting is hard, and the tolerance is currently set to 0.020. I'll now run the clash test. And once the test is complete, you can see that the model shows a total of 63 clashes. Next, we'll generate a clash report to document this result. I'll click on Clashes and then save the file as Clash 1. The report is now generated successfully, and it clearly shows that we have 63 clashes in the model. I'll press OK, and with that, we're ready to move forward to the next step. Now that we've successfully generated the clash report, it's time to upload it and proceed further. The first step is to check the BAMROC settings. Once you've installed our software, you'll see the BAMROC version displayed right here. Under this, you'll notice several prompt options. Run BAMROC increment prediction error, log file, account login and log out, about us, and the newly added maintenance settings, which was missing previously. Now, let's open the maintenance settings. This section allows you to define the required gap between components. For example, for ducts, I'll set a gap of 5 mm for pipe gaps, again, 5 mm. For cable trays, let's go with a 10 mm gap. For mechanical equipment, I'll stick to 5 mm. This feature helps me precisely define the clearance I want, making my work faster and more efficient. Once done, I can simply click Save to apply these settings. Or, if I don't want to keep the changes, I just click the Close to exit. This simple but powerful update makes maintenance settings more accessible, customizable, and user-friendly. Now we're going to take you through how BAMROC actually works, step by step. Let's dive right in. Step 1. Navigating to BAMROC. Once you open the software and press BAMROC, you'll be prompted with several options. BAMROC, Internet Prediction, Errors, Account Login Logout, About Us, and Maintenance Settings, which we've already discussed in detail. Step 2. Account Login. Now let's move to Account Login. Simply press the Account tab, and you'll be redirected to the login screen. We're now logged in successfully. Click OK, and you'll be redirected back to the application. Now go to Account Settings, and here you'll see your display name, token history, and an overview of your profile. Once done, simply close this tab, and let's proceed. Step 3. Preparing for BAMROC execution. Before running BAMROC, there's one important setting you need to know about. Section Box. Section Box is crucial for large projects as it lets you divide your model into manageable sections, speeding up the process. Right now, since I'm using a small project, I won't enable this, but for large-scale work, it's a must-have. Now I'll reopen all categories I previously closed, like ceiling, cable trays, and others. This ensures nothing clashes or overlaps unintentionally. Step 4. Running BAMROC. Now we're ready to run BAMROC. Click on the button, and before it starts, read the following prompts carefully. Ensure that interior, architectural, and structural files are properly linked. You can also draw a reference ceiling at the minimum tier height if no false ceiling is present. Make sure the MEP system is well contained between the floor slab and ceiling walls. And lastly, verify that all systems are connected and not disarmed. If everything looks good, accept the guidelines and proceed. Step 5. Choosing the BAMROC strategy. We have 2 BAMROC strategies to choose from. First, Move strategy moves the clash by the specified maintenance setting, for example 5 millimeters. Second, Bend strategy bends the element to resolve the clash. For this demo, I'll choose the Move strategy. Once selected, it will now ask you to choose the performance mode from the following 2. Medium performance mode. Fast resolves most minor clashes, uses 1 token per clash. High performance mode. Slower but stronger, ideal for tight clashes. Uses 3 tokens per clash. I'll go with medium performance mode. Now I'll press submit. The model is now being extracted. Elements are being scanned. The system now asks, do you want to upload a clash file? Click yes. You'll see a prompt saying, number of elements, 3,897. Clashes detected, 63. If we had used high performance mode, it would have deducted 189 tokens due to more intense checking. Press next. Step 6. Clash resolution. Now BAMROC begins solving each clash one by one. Since this is a small project, it won't take much time. Done. The prediction has been received from the server and is now available in your download folder. Click Close to exit this prompt. You'll again see tokens used 63. Now press Next. Step 7. Implementing the prediction. Now comes the most important step. Do you want to implement the prediction automatically? If you're using BIM 360, select No. You have 2 options here. First, Automatic. Predictions are applied automatically in the model. Second, Manual. You must open the electrical file in a separate tab and apply each prediction manually. For now, I'll leave the implementation options open. That's it for this part of the demo/tutorial. Now I'll take you through how to manually apply predictions and review the results for any edge cases. In manual mode, you first have to go into the manual settings, unload all the linked models, implement the prediction in each of them one by one, save them, then return to your main model and reload everything. Sounds like a lot? That's because it is. It's time-consuming and tedious. So what can you do instead? Let BAMROC handle it. I'll click Yes, and the process starts automatically. You'll begin to see a queue of operations: file opening, implementing prediction, saving, and reloading, all handled one by one. Right now, each file is being processed. BAMROC will first take the mechanical file, open it, apply the prediction, save it, and reload it into your main model, all on its own. The same steps you or your team would have done manually, BAMROC now completes without human intervention. It saves your time, energy, and yes, even your budget. Just sit back, sip your coffee, and relax. Now I can see demo 13 electrical being processed. Prediction has been queued and is now running. Watch how the tabs are changing. This shows that BAMROC is actively opening each file one by one and resolving clashes independently. This ensures high efficiency and 0 manual errors. The electrical part is now done. The mechanical file has been opened. Next, BAMROC will move to the plumbing model, and it's already running smoothly. Do you have questions? Reach out to us via email, and we'll be happy to assist you. This demo may seem smooth because it's a small project, but recently we worked on a model with 1,200 clashes, and BAMROC resolved all of them in just 25 minutes. Yes, 1,200 clashes, 25 minutes, fully automated. That's the power of BAMROC: fast, intelligent, and stress-free project coordination. Now the files are saved and the final step is reloading. Just a few more seconds to completion. Let's move to the next step, the Clash Resolution Diagnostic Report, CRDR. Now that the resolution is complete, I'll go to Manage. As you can see, we have 6 files here. The ones labeled Process are the resolved files. I'll select all the process files and press Unload All. And now it's time to export the NWC. I'll name it TP02, and the TP02 folder is being created. What I'll do now is the same process I showed you before. Here, I've displayed TP022, I'll rename it. Then, we head to the TP02 folder. Once I'm there, I follow the steps we all know. We go to Append, and I'll append TP-02 here. Once that's done, I go to the transcriptor. You'll see TP01 already there. I'll now add the test name as TP-02. Click the plus sign, and there you go. You can now see the process data on screen. I'll select both of them, and now I'll run the test. The tolerance is already set to 0.02. I'll click Run Test, and now take a look. Earlier we had 63 clashes, and now 0 clashes. Yes, just 0 clashes. That's how effective this process is. Finally, we'll make sure to close the clashes. And the CRDR part, we'll explore that more. CRDRBIM stands for Clash Resolution Diagnostic Report, and it's an incredibly useful tool. As a manager, if I want to understand what clashes are resolved, which are still unresolved, and which need to be manually corrected, CRDR helps me see it all at a glance. Let's dive in. First, I'll press CRDRBIM, and it'll ask me to select the folder location. I'll simply go to where I saved everything. That's in Demo 13. Once I open it, you'll see it detects the files. TP01 is found, and TP02 is found as well. That's why we name them that way. I'll press OK, and now it asks for the starting and ending clash numbers. Since we're working with 63 clashes, I'll enter 01 to 63. Then we hit Submit. Now it'll prompt for dimming options. You can choose New or All, but I'll go with 50% dimming for this demonstration, and I'll hit Submit again. Right now, the plugin is taking before and after screenshots of all 63 clashes. This helps us compare them clearly. This process typically takes 1 to 2 minutes, depending on the size of your project and the number of clashes. Now, if you're wondering where the photos are being saved, they're stored in the same location where your project files are. I'll name the output folder as Report, and I'll press Submit. It now says HTML files have been created at the BAMROC Reports folder. Let's open it. Here you can see 4 categories. 1. Resolved 2. Unresolved 3. Approved to be corrected manually. 4. Approved now. Say the current screenshot angle isn't clear or not showing the issue well. You can easily retake the screenshot from a different angle. Just rotate the model to your preferred view and click again. Simple and flexible. There's another feature I want to highlight, the Navigate function. Let's say I only want to view the before condition. That's TP01. I can hide TP02 and just see that. Or, if I only want to view TP-02, the after condition, I can toggle that too. Want to use cat color dimming? You can turn that on. Don't want it? Turn it off. So all these features are designed to make your work much easier, smoother, and more visual. Once you're done with the report, everything is automatically saved. Just go to the output folder, open the HTML file in your browser, press Ctrl+P and export it, or share it wherever it needs to go. You can now show what was resolved, what's still pending, what's been approved, and what's fixable manually. And that wraps up the Clash Resolution Diagnostic Report process. So far, we've explored the CRDR, the automatic prediction system, and the parameters that drive it. Now, there's one more important feature I want to show you. Let's head back to Revit. Here, I'll go to the Manage tab, then to Manage Links. What I'm going not to do now is unload these three models. After unloading, I'll load them back in. You'll see why I'm doing this in just a few seconds. Okay, all three models are now loaded again. I'll press OK and maximize the Revit window. Now I'll go to the BAMROC plugin. Currently, the model we have open is the Without Clash model. Now here's something interesting. When you're generating your prediction files, an additional file is also created called the error log file. What's the purpose of this file? Well, sometimes two models might get joined incorrectly, misaligned, or not symmetrical. This can create a new clash, a clash that was never actually there in the original design. This is where the error log comes in handy. So, I'll go to error in BAMROC. It will now prompt me to upload the error log file. That error log file will be saved in the same location as your prediction output files. Let's say I go and select the plumbing file. Since I know it's involved, I'll unload the plumbing file here first. Why? Because we need to open these models individually to inspect errors. Next, I'll open the PL model separately. I'll make sure to detach it from Central, and yes, the work sets are available. So now I have my PL part open. I'll close all the background models and keep only this one visible. I'll adjust the view so the elements are clearly visible. Then again, I'll go back to BAMROC, head to the error section, and upload the predicted file. In this example, we had 4 models, EL, PL, and 2 others. I'll upload PL specifically. Now BAMROC will highlight the exact error, the one that's causing the unexpected clash. This is incredibly helpful. Now what can we do with it? Well, if it's something fixable, you can go ahead and delete that misaligned element, or even use AutoConnect to correct it. If you're not ready to fix it, you can simply mark the clash as unresolved. That way, next time you or your team runs the model, you'll know that this issue still needs attention. And here's the best part. No new false clashes will be generated in the next prediction. This keeps your clash reports clean, accurate, and efficient. So that's the BAMROC error log feature, an incredible addition from Vavetek.AI. It's designed to make your workflow smoother, more intelligent, and easy to track. Even if you encounter unexpected or new errors, you're never stuck. BAMROC and Vavetek.AI are here to support you every step of the way. That's it from our side for now. Thank you for trusting us. Take care and thank you again.